Hello everyone, welcome back. In the previous sessions, we built and deployed our travel planner agent network using MuleSoft Agent Fabric. From a functional perspective, everything is working as expected. However, functionality alone is not enough for an enterprise-grade agent network. We must also ensure that the user's identity is securely validated and propagated across every agent, MCP server, and downstream API. In this session, we will establish a trusted agent identity architecture for our agent network using Okta. We will configure and test the OAuth 2.0 on behalf of token exchange flow, ensuring that the travel planner broker can securely obtain a new audience-specific token before invoking the protected Flights MCP server. We must answer some critical security questions. Who is calling the broker? Can the broker call the MCP server using the original user's identity? Can the MCP server verify that the token was specifically issued for it? And how do we stop an agent from consuming unlimited OpenAI tokens? We will answer all these questions by implementing a trusted agent identity architecture for our agent network. Here is what we will accomplish. First, secure the travel planner broker using JWT validation. Second, secure the Flights MCP server using JWT validation. Third, propagate the user's identity securely using OAuth 2.0 on behalf of token exchange. And finally, protect the OpenAI LLM proxy by applying token-based rate limiting. To implement this architecture correctly, we must configure several components in Okta, including authorization servers, applications, scopes, access policies, PKCE, and token exchange rules. Therefore, in this video, we will focus entirely on the Okta side configuration and establish the identity foundation required for our agent network. In the next session, we will configure the Anypoint platform and update our agent network project accordingly. Let us first understand the complete token exchange flow. The user first signs in through the OAuth 2.0 authorization code flow with PKCE. Okta issues a user access token for the travel planner broker. That token has API://travel planner broker as its audience and broker::invoke as its scope. The client sends this token to the agent broker using the standard HTTP authorization header. The broker's JWT validation policy verifies the signature, issuer, audience, expiry, and required scope. When the broker calls the Flights MCP server, it must not simply forward the same token. Why? Because the original token was issued for the broker, not for the Flights MCP server. Its audience is incorrect for the downstream service. Instead, the OBO policy exchanges the original user token for a new downstream token. The new token has the Flights authorization server as its issuer, API://Flights MCP as its audience, flight::hold as its scope, and the original user in the subclaim. The Flights MCP server then validates this new token before executing its tools. This is trusted delegated identity. The user identity is preserved, but every service receives a token created specifically for its own security boundary. Now, let's configure Okta. For this setup, we need an Okta integrator free plan. First, we will create the native application. From the Okta admin console, navigate to Applications, click Create App Integration. Select OIDC. OpenID Connect as the sign-in method, choose Native Application as the application type, and then click Next. Enter a name for the application. Next, configure the sign-in redirect URI. For this demonstration, I am using the Postman callback URL. Under Controlled Access, select Allow everyone in your organization to access, and then click Save. Once the application is created, copy the client ID. We will use it later to obtain the initial user access token. Now, click Back to Applications. Next, we will create the service application. This API services application represents the travel planner broker during the OAuth 2.0 on behalf of token exchange. Enter the application name. Click Save. On the General tab, locate the General Settings section and click Edit. Under Grant Type, expand the advanced options, select Token Exchange, and then click Save. Next, copy the client ID and client secret because we will need them later while configuring the on behalf of policy. With both applications created, we can now proceed with configuring the custom authorization servers. Next, we will configure the first custom authorization server. Its audience will be API://travel planner broker. Add new access policy and assign travel planner UI as client. Add new rule to expose the scope broker::invoke and assign users. This authorization server issues the initial user access token for the travel planner broker. Next, configure the second custom authorization server. This authorization server issues the exchange downstream access token required to invoke the Flights MCP server. Its audience will be API://Flights MCP. We will configure the travel planner broker authorization server as a trusted authorization server for this server. This trust relationship allows the original user token to be exchanged for a new downstream token. Add new access policy and assign travel planner broker OBO as client. Add new rule to expose the OIDC scope, flight:/hold, and make sure you are selecting only token exchange under grant type section. Now, let's test the complete token exchange flow from Postman using the configuration we completed on the Okta side. Before creating the request, open the issuer metadata endpoint for the travel planner broker authorization server. From this metadata document, copy the authorization endpoint and token endpoint URLs. We will use these URLs while configuring OAuth 2.0 in Postman. Also, make sure you have copied the client ID of our Travel Planner UE native application. Now, let's return to Postman and create a new request. Enter the Travel Planner broker endpoint as the request URL. Next, open the Authorization tab and select OAuth 2.0 as the authorization type. Under Configure New Token, enter a meaningful token name. For the grant type, select Authorization Code with PKCE. Enable the Authorize using Browser option. This allows Postman to open the Okta sign-in page in your browser and complete the user authentication flow. Now, paste the authorization and the token endpoint from the issuer metadata document that we opened earlier. In the Client ID field, enter the client ID of the Travel Planner UI application. Next, enter the required scope. For our Travel Planner broker, the scope is broker::invoke, enter a random value in the state field. Postman uses this value to correlate and protect the authorization request. For client authentication, select Send Client Credentials in body. Verify the configuration and then click Get New Access Token. Postman will now open the Okta authentication page where we can sign in and obtain the initial user access token for our Travel Planner broker. After you authenticate successfully, Okta redirects you back to Postman. Click Proceed and then select Use Token. Copy the generated access token. This is the initial user token issued for our Travel Planner broker. Now, let's create another request to verify whether the OAuth 2.0 token exchange is working correctly. For this request, use the token endpoint of our second authorization server, the authorization server created for the Flights MCP server. Set the request method to post and configure the body using the URL encoded format. Specify the grant type and subject token type as you see on my screen. These two values are important because they tell Okta that this request follows the RFC 8693 OAuth 2.0 token exchange flow and that the supplied subject token is an access token. In the subject token field, paste the user access token that we copied from the previous request. For the audience, enter the audience configured for the Flights MCP server, API://Flights MCP. For the scope, enter flight:/hold. This means we are requesting a new downstream access token specifically for the Flights MCP server with permission to perform the flight hold operation. Make sure the request also includes the client ID and client secret of the Travel Planner Broker OBO API services application. Now, let's send the request. Great! Okta has successfully exchanged the original broker token for a new downstream access token. In next session, we will use this token to invoke the protected Flights MCP server endpoint.